Alright, so let us do one more problem on flowcharts. So in this problem, we want to find the greatest common divisor of two numbers, okay? And it is also known as GCD or HCF. So for example, let's say there is a number A that is 8. There is a number B that is, let's say, 12. So what is the largest number that divides both of these numbers, okay? So by intuition, we can see this number is nothing but 4. 4 is the largest number that will divide 8 and 12 both. Okay, for example, if A is 8 and B is, let's say, 24. So in this case, the GCD would be nothing but 8, because 8 divides 8 and 8 also divides 24. And maybe there is a number, let's say A is 9 and let's say B is 11. In this case, the GCD is 1. There is no common divisor except 1 between the two numbers, okay? So if you look carefully, you can say that if you have a number A, let's say, and a number B, so we can clearly say that the GCD of these numbers A and B would always be less than equal to minimum of the two numbers, okay? It would always be less than equal to minimum of the two numbers. So for example, if A is 8 and B is 12, so you cannot have a number that is greater than the smaller number that will divide both, okay? So you cannot say I will have a number 10 that will also divide it. No, this is not possible. The GCD would always be less than or equal to the minimum of two numbers, and the minimum value of a number that can divide both the numbers would be 1. So we can say that the GCD would lie in the range starting from 1 to the minimum of A comma B, okay? So this would be the range, so that we know that our answer would always lie in this range, okay? So we are trying to build a very brute force logic for computing the GCD, okay? And we are going to try out all possibilities, what numbers can be a GCD of a given number. So this we know, and if we know this, we can easily iterate over this range using a loop. And now we want to find out the greatest number in this range which divides both A and B. So let us see how we will build this particular algorithm. So let's take an example. Let's say A is 8 and let's say B is 20, let's say. So what is minimum of A and B? It is of course 8. So we'll iterate over the range 1, 2, 3, 4, 5, 6, 7, 8. So in the beginning, we are at 1. Does 1 divide A and B? The answer is yes. And we will update our GCD, okay? So what is the largest number we have seen that divides both? That number is nothing but 1. We go to 2. Does 2 divide A and does 2 divide B? The answer is yes. So we will update our GCD as 2. Does 3 divide both? 3 does not divide 8, it does not divide 20. Does 4 divide 8 and 20? Yes, it divides. 4 divides 8 and 4 divides 20. So hence the GCD is 4. Now we go to 5. Does not divide, does not divide. We go to 6. Does not divide, does not divide. We go to 7. Does not divide, does not divide. We go to 8. 8 divides 8, but 8 does not divide 20. Okay. So that means what would be the value of GCD in all these iterations? We have not updated the value of GCD in all of these iterations. So finally, the GCD would be nothing but 4. Okay. The GCD would be same, that would be 4. So we found out 3 numbers, 1, 2 and 4, that divides both 8 and 20. Hence the largest number is 4, and hence the GCD is 4. Now take a pause and think, can you come up with a flowchart to solve this problem? Okay. Now let us discuss the solution. Let's solve using a flowchart. The first step would be start as usual. Then it would be read the two numbers, that is read A and B. And now what we are going to do, we are going to initialize what? We are going to initialize, let's say I, that is equal to 1, and we are going to go till minimum of a and b. So if I is less than equal to minimum of a comma b, okay, if it is yes, so what we are going to do, we are going to check if I divides a and I divides b also. So we are again going to put a decision box here. Is a divisible by I and b divisible by I? If the answer is yes, okay, then what we are going to do, we are going to update our GCD. So we are going to say that our GCD is equal to I, because I is the largest number so far. We have seen that it divides both a and b. That divides both a and b. So we have to complete this branch of no, and we have to complete this branch of no as well. So after updating GCD equal to I, we will go to the next I, that is I equal to I plus 1. And even if I does not divide a and b both, then also we will go to this next branch and we will say, okay, I equals to I plus 1. And from here, we are again going to connect back here. We are again going to connect back here. So if we come out of the loop, that means we have explored all options. What we are going to do, we are going to print the value of GCD. So we can say, okay, print the GCD, the greatest common divisor, and that's it. That's exit here. Okay, so we are done. Now let us try to dry run this code for, let's say, 6 and 4. Okay, let's say a is 6 and b is 4. Let's say this is what a and b is. So we'll run this code from 1 to 4. Okay, so when I is 1, is 1 less than minimum of a and b? So minimum of a and b is 4. So is 4 divisible by 1? Is 6 divisible by 1? Yes. Is 4 divisible by 1? Yes. So what we do? GCD equal to 1. So our GCD is 1. Great. We go to next number, I equal to I plus 1. I becomes 2. Is 6 divisible by 2 and 4 divisible by 2? The answer is yes. So we again go here and we update our GCD. GCD is 2. We go to 3. The next number, that is 3. Is 6 divisible by 3? Yes. Is 4 divisible? No. So we do not update our GCD. We simply take this route and go to the next number. We go to 4. Is 6 divisible by 4? No. Is 4 divisible by 4? Yes. So we don't update our GCD. So GCD remains same, that is 2. So finally we make I as 5, and 5 is not less than equal to minimum of a and b. So what we do, we come out of this loop, we print the GCD, and then we exit. That's all. That is how we have computed GCD using a very basic solution. Okay, so there are optimized algorithms to do it. There is a Euclid's algorithm, but that would not be covered yet. It's a slightly advanced algorithm, and this is the most basic way of computing the GCD. So that's all for this video. Thank you.